Yes, sir. Your screen is visible.
So whatever we have studied in that by hand process, that can be also implemented in MATLAB, or the program can be written just like this AND NOT gate. So this is the program for realization of that AND gate. I'm running it. It is asking when I will run it. It is not working. Means MATLAB. So enter weight. I suppose I have entered the value of one weight W1 and W2 1 and entered the threshold. I have entered this threshold value is also 1. So you will clearly see that network is not learning. Enter another set of weights and threshold value. So if I am giving the input of W1 1, W2 1 and threshold 2, still it is also saying that network is not learning. Enter another set of weights and threshold value W1 2, W2 2 and W3 2. Again it is saying that network is not learning, means these weights and thresholds are not giving us the desired output whatever we are having the requirement or whatever the target output. So we have adjusted that W1 is 1, W2 is minus 1 and theta is 1. So in this case 1, minus 1 and 1. Actually I have run several times. 1, 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1, 1. So now you can see that I have given the input W1 as 1, W2 as minus 1. So output of network is 0, 0, 1, 0, which is our desired output. So now it will, that output is matching with the target value. So it will give us the value of weights of neuron are 1, minus 1 and threshold is 1. So W1, W2 are 1 and minus 1 and threshold is 1 that we have decided this uh, in this case, that if W1 and W2, this threshold is 1 and W1 and W2 are minus 1 and 1. Now how to use this neural network tool which is already given in MATLAB. So for this you will write here as NN tool. So in this you will say that this is input data, target data and network. So what we need to do, we have to given for the training purpose, you need to give some input and the target. So in this case we will create one input file. This is input and then new data, that is target. Now for this input and target we need to provide some data. So I am using this neural network in load forecasting. Different parameters are there and the accuracy of output will depend on type of data or the accuracy of data. So I have considered this as sample test data. It might not be too much accurate or it will not give the too much predicted or too much correct results, but this will help you in uh, applying the neural network toolbox in load forecasting. So these are the few parameters: date, time, week, then day of week, weekend, holiday, or which holiday ID, hour of the day. Then these are the 11 input. So I have considered and then whatever data you are having, consider around 70 to 75% data for training the network, and then the remaining data will be used for testing, that whether whatever model we have trained, whether that is giving satisfactory result or not. So these are around 500 data are there. So I will consider approximately 350 for the training purpose. So I have selected these 350 inputs for, these are the input. So I will give as an input to input file. Then transpose this data. The transpose will help you whenever you will make a model. At that time, I will give you the explanation about this transposition. Then next is target. So I will select these value, means for this input, or this is the data which is already given. So this I will select this, and in target I will give it as input. I will also transpose it. Target is equal to target transpose. Now it is, sorry, this is spelling is not correct. Target is target transpose. So now it is also transposed. Now come to this neural network toolbox. Here you have to import data. So import, there are two options: import from MATLAB workspace or load from disk file. So we have created this input data in workspace, input and target. So we will import this data from this workspace. So input, the name is input, and it will be imported as input data. So imported, you will see that variable input has been imported as input data into network or data manager. Similarly, import target into target data. So now imported this. Now close this. Now this input data and target data, these two data, these two have been imported in this network or data manager. Now create this new. Create this new. This in this case we are creating a neural network. So this neural network can be created by name NET. Here you will see that network type. So if you will go in the drop down, you will find different type of neural network: perceptron, probabilistic, radial basis, self-organizing, generalized regression, fast forward time delay, or fast feed forward back propagation. So different type of network you will find in drop down, and you can select as per your requirement. Then input data will be taken from the input which we have selected. Then target data will be this target. Training function you can also select as per your requirement. Then that this performance function you can select as per your requirement. Number of layers, generally two layers will be there. Then if you want to increase the number of layers, you can increase number of layers as per your requirement. You want to change 3, 4, 5, whatever you have requirement. Then these are the layers for the properties. Layer 1 is input, layer 2, layer 3. In layer 3 you will not be able to find the number of neurons because that is output layer. Layer 2, if you want this number of neurons can be increased, you can make it as 20 or 25, 30, whatever you want. Similarly, in layer 1, you want to increase the number of neurons, you can increase the number of neurons. transfer function, this log sigmoidal, 10 sigmoidal or pure linear, you can select this for layer 1. For layer 2, this is the activation function. Actually, we are setting the activation function. So in layer 2 you can select as 10 sigmoidal, and for layer 3 generally it is selected as pure linear. Then create. If you will create this new network called net added to network or data manager, now you will find this network here. Now double click on this, you will find this network. Now see, there are 11 inputs. What is our objective? For we are providing these 11 inputs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 inputs, and corresponding to these 11 inputs, we are getting one output. This is our objective, that we will give 11 input and output is demand. Basis on this data, a network will be formed, which is a trained network. Then once that network is formed, we can say that we will give input and we will get output. We will give 11 inputs and correspondingly one demand will be there, and that demand is predicted demand, that we can predict that demand will be this on so and so date if we are able to give these parameters. So this is basically application of neural network in load forecasting. So here, that our network is properly giving the output or not. So 11 inputs are there, output is 1. So if we will not transpose this data that we have initially transposed, then this network structure will not be in such a way. In that case, you will get some 350 inputs and output maybe 350. You can also see the type of activation function which we have selected. In output layer we have selected pure linear, so output is this activation function is showing as pure linear, and in hidden layer it is showing as sigmoidal. Clear? Then we need to move to the train section. So input will be input, target will be target. Then you can adjust the training parameters here. I am considering these by whatever default parameters are given. Now you will train this network. So click on this train network. Here you will find some the parameters, that epoch, time, performance, gradient, validation check. Now for this purpose you need to check these parameters: training state, regression and performance. The actual parameter variation will be as per your problem, but generally this regression plot which is coming, plotting this regression plot, this one. So this should come approximately 1 at all places. This 9983, 9898, 99158, 96498. If it is not approximately 1, then you can again train this. Means we are not getting the exact model. So you can again train this and try to achieve 1 or approximate 1 at all positions. So 0.996, 0.994, 0.991. So I'm considering this as that my desired objective is achieved. So next stage will be, what I will do, that now I am saying that my network or my neural network is trained. So if my neural network is trained, so I need to export this network. So I will export this network. I will select this net and export. Now variables have been exported to workspace. So I will check in workspace. There is one network, net is there. So I have made one neural network from input data and target data. Now I need to check whether this network is properly trained or not. So the remaining data which we have kept for the testing purpose. So that testing data will be provided as an input, and we will check the output of that test data, that whether that input is proper, that input, once that input is given to this neural network, it is giving output or not. So we will consider the remaining data for testing, which we have kept for testing. So this data we have kept for testing around 150 inputs. So we have selected this data, and now a new data file will be created as test. We have created this test. Now again transpose this. So we have considered this test. This test input are loaded in MATLAB workspace. Now we need to calculate the output of this network for this test signal. So this will be tested. So I can write it as A. This will be equal to A. Whatever you want to select, you can you want to write, you can write it as A, B, C, or output, whatever you want to write. Sim, then net. This is the network which on which we want to implement this data. So net, comma, then what is the input? Input is this test. So this is test. So now we will get the output in, or this is A is the output of this trained neural network for this test data. Then now we need to check whether this data or this output data which we have predicted, or we can say that this data is predicted data. So this predicted data is matching with the actual data or not. So for that purpose we need to import this data, and then we can compare that. So this data has been imported. Select. Then this is A. I can create another data set A1. Suppose this, we will compare this A and A1. A is the calculated one and A1 is the actual one. So A1, this is equal to A1 transpose. So I can compare with this. This is A. So now plot this A. I have plotted this A, and then I will hold this and will plot A1. Now you can see A1. I can change the color for A1. You can clearly differentiate this. A1 means A1 is actual and A is predicted one. So we can see that sometimes this predicted one is high and sometimes predicted one is low. So it means we need to change the variables, because I have explained the process, results, and value of parameters, algorithm, that will depend on your requirement. Whatever requirement, or this model will be trained unless until you will get the desired objective. Once you have received the desired objective, that these two graphs are nearly overlapping. Nearly overlapping means that the output which we are taking from the trained network for the test samples is matching with the data which is actually available for that duration. It means our neural network is working satisfactorily, or our neural network is perfectly trained and it can be implemented to another data also. So then parameters you can change, and that accuracy will depend on type of data also. If the data is not perfect, in that case also accuracy may vary. So in today's session, I have explained about the neuron. Then after neuron, we have discussed about artificial neural network, its topology, its learning algorithm. Then by hand uh, solving that AND gate and OR gate and adjustment of weight, and then ultimately use of neural network tool in the forecasting. So this is my contact number, mail ID, and if you want to study more in detail about these solved problems of XOR gate and NOT gate, then you can find the different videos on my YouTube channel. This is the link for the YouTube channel. You can also find that YouTube channel as name that Electro Gyan. Electro Gyan, a class by Dr. Vikas. So thank you so much. It's That's all from my side. From and any question from the participant side?
All the participants are requested if you have any sort of query or any doubt regarding today's session, you can please pose your query in